Welcome back to our live coverage here at the AWS AI Infrastructure Innovation Day. Thank you all for joining us. Thanks for hanging out with us. I'm AM. I'm one of your hosts. Got Jasmine here with me all day.
Hello.
And we've got some new friends to meet down at the other end of the table. Sunita, you want to kick it off for us, please?
Yeah, sure. I'm Sunita Nadampalli. I'm a software development manager. I lead the Graviton optimizations for machine learning and high-performance computing workloads. And I'm also the PyTorch maintainer for ARM CPUs.
Oh, that's interesting.
Yeah.
Jeff?
Yeah, hey folks, my name is Jeff Underhill. I'm part of our worldwide specialist organization focused on efficient compute technologies, which includes AWS Graviton, which is what we're going to be talking about today.
Yeah, I mean, people might be, very interested why we're talking Graviton, obviously CPU, right?
Yeah.
I think people are very familiar with GPU workloads when it comes to AI/ML. Where does the intersection meet here with GPU and CPU? Do you want to talk about that, Jeff?
Yeah, sure. So you mentioned intersect. It's kind of interesting, right? So if you think of it as a continuum of compute for AI/ML,
right.
Basically it's a compute-bound problem, right? Or in some cases bandwidth-bound, but there are pieces that you can run on the CPU. I've seen a lot of people training models using SLMs today and optimization techniques, which make models a great fit for running on CPUs. Sure, there's a place for accelerators, and they're amazing technology. But there's pieces you can run on a CPU, and then there's probably a bit of overlap in the middle, and then there's a tipping point where you absolutely need accelerators. So what we want to do today is talk about that portion that belongs on a CPU, and not to steal any thunder, but we may even have a demo and show you it running live a little bit later on.
We better have a demo soon.
Yes.
Okay, good. I knew you wouldn't let us down. I knew you wouldn't. Here.
Just to add to Jeff's point, right, about that. So let's look at the bigger problem that we are solving here. So if you look at the AI/ML workloads today, they are so diverse. When it comes to model sizes, there are models anywhere from a few million parameters all the way to several 100 billion parameter sizes. And when it comes to usage, there are offline use cases with very large batch sizes, and at the same time, real-time and single inference scenarios too. And traffic patterns, same, continuous and also very intermittent and non-deterministic. So if given all these, it's not possible for a single framework or a solution to fit across all these broad range of scenarios. So that's where we at AWS are, providing more and more options for our customers to choose from when it comes to deploying their machine learning inference workloads. So in this context, we are actually innovating and improving our CPUs, that is Graviton instances, for deploying ML inference.
Yeah. So what does this look like? You're talking about the scalability of going from just a few million parameters to billions and billions of it. So what does this look like, and what are the types of customers who might leverage this?
Yeah, I mean, so as Sunita mentions, there's a range of model sizes. There's a range of input context that people use. Different people will have different requirements on the latency, the rate of output from their models. All of those parameters kind of feed in, and you got to essentially experiment and determine which things are fit for you. We have a great example. Actually, you co-authored a blog, Sunita, with a company called Sprinkler. We have a QR code at the end. So they were running actually a variety of AI workloads on Graviton, a Graviton 3 processor. And they saw, I want to say it was 20 to 30% performance improvement and about 25% cost improvement from moving their models to run on Graviton. So yeah.
Yeah.
Very nice. I'm a big fan of Graviton personally. I coming from the dev world more than the AI world, for me personally, Graviton was huge on Lambda. I was a big fan of Graviton getting added to Lambda. So I myself have seen the efficacy and performance boost that you get, right, with switching to Graviton. So can we talk about that just a little bit? And I know maybe we want to talk about a very recent launch as well.
Yeah.
What do you all want to cover? Why does Graviton fit so well in this AI/ML?
Well, so maybe a little bit of history here. So I'm old, I got gray in my beard, right? If we go back and look at CPUs, AI/ML has been run on CPUs for a long time.
Mm-hmm.
It's at the forefront right now, and it's very popular. And CPUs have evolved a lot over that time, right? Back in the very early days, a CPU didn't even do floating point math. You had a coprocessor that would sit alongside it. And somewhere along that journey, GPUs were for graphics only, right? And then people started looking at GPUs saying, how can I harness that compute power and apply it to more general purpose problems? Mm-hmm. And that's where we see today. So CPUs have advanced, GPUs have become more general purpose. Specifically with Graviton 3, we introduced that a couple of years ago. It's available in a variety of instance sizes worldwide. And there's a couple of features in there specific to running AI ML workloads efficiently. So bfloat 16 is an example. There's int8 support in there, FP 16.
MMLA instructions to do matrix multiplications in the hardware directly.
Okay.
And not only that, over the previous generation, right, it doubled the width of the floating point unit, so twice the amount of math operations.
And it's not just ML. We have been adding throughout as a system overall. For example, much better branch predictor and 50% more DDR bandwidth too.
Yeah, good call.
Combined.
Interesting.
Yeah, so Graviton 3 was the first instance on EC2 with DDR5 memory. So yeah, adding all that compute performance, you got to be able to feed it, right? If you add a bunch of compute performance, but you can't get the data in there, you can't utilize it, right?
Yeah.
So that's Graviton 3. You alluded to.
That's right. I was at the New York Summit, a few weeks ago. There was some exciting news from Graviton around that time
There
period.
was. So July 9th, to be specific, we launched our 4th generation of Graviton. The instance type is RAG. So all that goodness in Graviton 3. With Graviton 4, we take it a step further. We've got more powerful cores in there. So we have higher single-threaded performance. It goes up to 96 cores. So Graviton 3 stops at 64 cores. So we have a larger instance families. We added extra DDR memory channels. Again, feed the beast. So we went from 8 channels on Graviton 3 to 12 channels on Graviton 4.
Yeah.
But wait, there's one more thing. Not only that, the DDR5 went from DDR5 4800 to 5600 too, right? So wider, faster, more performance. And that's going to enable us to run even higher sized models, right, on Graviton 4.
Incredible. Yeah, Sunita, before we jump to your demo, which you know me. I'm always
I want to
pushing
see
for
the demo.
But before you mentioned, working with PyTorch and ARM. Can you talk to us a little bit about, anything you worked on around Graviton and ARM, specifically with AI ML too? I think that's really interesting as well.
Sure. Of course, we partnered with ARM to bring all these great Graviton features into the leading machine learning frameworks. For example, if you take PyTorch starting from 2.0 and TensorFlow starting 1.9 and latest Llama CPP and OnX and, scikit-learn, XGBoost, all these frameworks, they natively support Graviton features.
Okay.
And we being the maintainers for some of these frameworks, we are actively monitoring and also improving the features from release over release.
Right.
Yeah.
And I think one of the things that customers have called out is the improvement in latency. What does that look like?
So for example, if you take the PyTorch 2.4 that was just released a week back, so there we delivered the torch compile optimizations for Graviton. So what it means to end user is when they those optimizations, when they deploy their models across NLP, CV, or recommendations, they could get up to 2x better performance, meaning 2x lower latency or 2x higher throughput compared to the previous releases. So that is the level of optimizations we have been, contributing to these frameworks.
Yeah.
And there's a really important point there, right? So I talked about the hardware innovations that come generation over generation. If that isn't supported in the software, right? So having the best hardware on the planet without software that supports it is kind of a moot point. So, Sunita and the team keeping in lockstep there, making sure that we're contributing to the open source communities. All this support is upstream as we're releasing new instance families. Makes it readily available for customers to consume via the channels that they're used to consuming it, right? So reducing friction, making this technology instantly available to customers.
Yes.
Yeah. And we're getting some questions in the chat here because I know that we're live. And then, Sunita, we want to get to the demo. But folks are asking about what does this mean for sustainability?
Oh, that's a great question. So, Graviton itself is super energy efficient design. Not only that, but at the rack level, there's innovations. We can pack them more densely in our data centers. So we've seen up to 60% improvement in sustainability when running workloads on Graviton. Now, that is comparing getting the same amount of work done with a Graviton versus some other instances. Not only that, though, the performance aspect plays into that. So if you're able to run your workload and reduce the number of instances that you run them on, infrastructure that you aren't using is the best way to save energy, right? It's like if you literally are using less infrastructure, and then the infrastructure you do use is more sustainable as well. So yeah, it's a big plus, and a lot of companies are taking carbon emission goals and looking for sustainability improvement. So Graviton can help in that respect.
Yeah.
Very cool. All right, Sunita, you're actually going to deploy a model out for inference on Graviton for us live, yeah?
Yeah. That's what we
No
lined
big
up
deal.
here.
No big deal. Very
So just to set to some context, right? In general, we have seen Graviton instances being suitable for anywhere from traditional machine learning workloads like ranking, classification, all those, regressions and decision tree based, and also the deep learning models like speech recognition and sentiment analysis or recommenders. But in this context, I'm going to focus on Gen AI demo. So for which we are kind of, we have seen mostly it is suitable for domain-specific chatbots, something like, either employee human resource services or administration for medical, school, or banking in that domain. And especially those chatbots which are powered with smaller to medium-sized medium-sized models. So what it means is anywhere from 3 billion, 8 billion, 13 billion, or even up to 30 billion parameter models is where we have seen Graviton instances are suitable for. So today I have a demo lined up of using one of those 8 billion parameter models.
Okay. Let's take a look. All right, we got your terminal up.
Okay, for this demo, we are going to use Llama CPP, which is one of the optimized frameworks for Graviton. And the framework also comes with, some of the cool tools to quantize the model and deploy it on a local machine. So this is one of the recommended ways to get LLM inference running on Graviton at this point.
Okay.
And for the instance-wise, I'm using Graviton 3-based instance, that is C7G16X large. And for the model, I'm going to use Meta Llama 3.1 model. So as you know, which was released just a week back, I think less than a week. Yeah, this is the latest. And for this demo, I'm using 8 billion parameter one. The model download takes typically some time. So to save the time for us, I have already kept it downloaded. So here
you said something interesting there while you were introducing your demo here. So quantization, right? So that's an optimization technique where you essentially trade off precision for performance and size of data, right?
Exactly. So this is an FP32 model, but of course one can directly run this model and get the inference done. But as you mentioned, it is highly recommended to quantize this model, mainly to get the performance advantage, which is actually manifold given the acceptable accuracy it provides. So I'm going to show you how to do the quantization using Llama CPP.
And just while you're doing that, so that is a general optimization technique, right? That's not something unique to Graviton.
Correct. So this is, of course, across all over ML field or Gen AI field. Quantization is one of the recommended techniques. And Llama CPP provides tool to quantize, and also it provides multiple optimized performance optimized gem kernels. So what it means is at the end of the day, all these machine learning or Gen AI, they heavily depend on low-level kernels to do the math operations, right?
Okay.
So those are called GEM. So it's an acronym for General Matrix Multiply and Accumulate. So we partnered with ARM to optimize all quantized gem kernels for Graviton specific instances using their hardware features like MMLA instructions and int8. So, and they're already upstream too. So today, if you go and take Llama CPP mainline, you get all the optimized kernels by default.
And just while we've mentioned SLMs a couple of times, right? Small language models.
Yeah.
So that's one of the things. So using quantization and prompt engineering and retrieval augmented generation, these are techniques that improve the efficiency of models and just increase the applicability of running them on CPUs over time, right?
Okay.
Very nice. So we're going to talk about a few of those metrics, so to speak, of how you evaluate the performance of a model, right?
Yes. So right now I'm showing how to do quantization using Llama CPP. I'm using the default tool, Llama Quantize. All we are doing is giving an FP32 model and quantizing it to Q4. So by the way, this is a one-step operation so that customers generally, you can go and you can do it as an offline pre-processing step for a given model before deploying it into the production.
Okay.
So it's already done even before, we are talking about it.
Yeah, so that's like a 10-second investment for a huge return.
Yeah.
So you said it's one time too, Suniti. You could store this centrally and have other workloads reference where
Exactly.
That's it. It's
Exactly.
done one time.
Do it one time and distribute as many times as you want.
Nice.
And now the quantization is done and it's ready for deploying. But before getting into the inference, I would like to show or talk about what we really care in this demo, right? What metrics do we really care about?
Yes.
Yeah.
Yeah.
So traditionally for deep learning models, it is we generally use request per second. That is the metric we are so much used to. But for the generative AI models, generally there are two such metrics. So the one is the prompt encoding latency, and the second one is the token generation latency or token generation throughput. Let me tell you why two and why are important. So especially for the chatbots, the prompt encoding means the time it takes to encode the input context or input text that we provide and understand the context. So for chatbot, it means how much time the user has to wait before they get their first response token, first response word. And the next one is the token generation rate. So what it means is how fast the model is generating the token responses or the words in sequence, one after the other. So that actually decides how is the user experience when they're actually consuming that response from the model. Right?
Yeah, I was going to say, Sunita, to me, app dev over here, it sounds like these are cumulative towards the total latency across the entire application.
Yeah.
Right. And you want to reduce latency as much as possible, almost always.
Correct.
And now you're going to show us this, right?
So-
we're going to actually see it in action, right?
Exactly.
Cool.
So this is the Llama CLI I'm using. Llama CLI is a native client to run, LLM inference on local machines. All we're doing is providing the model, that is the quantized and saved model. I'm just providing one sample prompt. And here that 512 is nothing but the number of tokens that we would like the model to generate. I think 512 is a decent number to get the response details. And finally, I'm using 64 threads on this machine. So it actually dumps a lot of metadata, and then it starts dumping the responses. So here you go.
And that's it. It's interpreted your question and it's already responded, right? It's generating the and you said up to 512 tokens, so it's going to spit out. Okay.
And this is going faster than we can even read it.
Yeah.
So that you make a really good point, right? And that's one of the key metrics here. So the general goal that people aim for is 10 tokens per second or 100 milliseconds per token, because that's the fastest possible consumption by a human, right? So if you're spitting that out and you or I are interpreting it, it's far faster than we can interpret it.
Yeah.
So as you can see here, as Jeff mentioned, as you can see here, we have two metrics. First one is the prompt encoding. So let me highlight that. So the first one is the prompt encoding. Here it took around 3.4 milliseconds to encode one prompt, or to make it more realistic, right? It took around 50 milliseconds to encode the context we gave, which is hardly anything for a human. And for the response generation, it took around 22 milliseconds per token. So what it means is it was generating 45 tokens per second. As Jeff mentioned, it is much, much beyond, someone human readability.
Right.
So what it means for the for customers is they'll be able to either go to the lower thread count systems or batch more and more such multiple client requests into a single instance. That way they'll be able to use the instance to the fullest.
Right.
Right.
And this is where, the power of the cloud comes in. You've got access to all these technologies to experiment, determine for your specific use case, right? Whatever your targets are, whether you want to run higher batch sizes or shrink and run on lower instances to run as efficiently as possible for your specific scenario, right?
Right. And speaking of, you were running on a Graviton 3 instance, right? We're very short on time. I don't know if we're going to be able to see you run it on Graviton 4. I imagine you've got that pulled up.
Exactly. Yeah.
Spoilers, it's faster, right?
Yeah.
So just in case we have to fail.
Do it.
Yeah, just to save
Side by
time.
side.
Yeah, just to save time, I kept everything ready. I'm going to start Graviton 3 first, just to be fair.
Let's do it.
Yeah, I started both. Top window is 3 and bottom is 4.
All right, there we go.
Love a race,
And there you go. Yeah.
Yeah.
Graviton
Graviton 4 is already way ahead. Yeah.
4 is already done. 3 is almost, of course, close to getting done.
If it was
3 is done as well.
competition, 4 would already be on top of the podium.
Yeah.
So here, if
I'm
you look
at the after party, I think. Yeah. Anyway. Sorry, Sunita. Go ahead.
just if you look at visually, right? Visually we have seen, but metrics clearly show that the token response generation is 45 on Graviton 3, went up to 65 on Graviton 4. So which is more than 40% improvement from generation to generation.
Yeah.
I wanted to point out too, just real quick, you had been putting in some parameters to that CLI command too. That was the amount of threads used, and you weren't even using the full extent of Graviton 4.
Exactly.
And
So
it's
because
still
I want to
performed.
compare the same configuration, I used exactly the same 64 on both.
So we got to run, unfortunately. But where can our audience learn more?
Yeah, we have one slide with all the QR codes.
Okay, let's get that up there for just a minute. There we go. All right, let's.
So, the same demo can be replicated using either Amazon EC2, ECS, EKS, or even fully managed Amazon SageMaker service. And we also have some resources for customer blogs.
Okay.
Thank you both for being here.
Thank you.
Really appreciate it.
This is great.
Thank you. Yeah.
For all of you at home, stick around. We'll be back with more.